Yeah, moving on to the next paper, that's in fact from my own lab. So I would like to welcome Pulkit online. The paper is on interpretability analysis of symbolic representations for sequential decision-making systems by Pulkit Verma and Julie Sa. So go ahead, Pulkit.
Hello everyone, I am Pulkit Verma from MIT, and today I talk about interpretability analysis of symbolic representations for sequential decision-making systems. So why interpretability matters for human AI collaboration? So most of the AI systems that we know can do some sort of planning for human AI collaboration, and they are sequential decision-making systems. So to increase the trust and transparency, it is very important. And we also know that humans need to understand how the robot is making these decisions to improve that trust and transparency. But most of the work on interpretability of AI is in the area of single step decision making systems. And there's a large gap if you talk about interpretability for sequential decision making systems. So, what exactly are sequential decision making systems? So, these are the kind of AIs that make series of decisions over time, and they are often modeled as smart code decision processes or MDPs. But they have unique interpretability challenges because they have some form of temporal constraints among them, and they have very complex state spaces, right? And there is always some sort of trade-off going on between interpretability and performance. And there are multiple symbolic representations that can be used. But since we are short on time, I will just talk about two or three of them, and then you can refer to the paper to learn about all of them. So first are finite state machines. In this, we have state transitions and their associated actions, and they are very intuitive for a user to understand because they have this graphical representation. Here on the right, you can see one such a representation, which is, I know, a bit complex, but it can be easily converted to a more natural language form while retaining the form of this graph. But they kind of struggle with nuanced continuous reasoning, and also if they are at a grounded object form, so there are scalability challenges because if my state space is large, these graphs can become very huge, so they are not suited for high dimensional spaces. Another thing that I have worked mostly on is planning domain definition language. Here you represent the state in form of these first order logic predicates. And here, as you can see, an action has precondition and effect. So preconditions are the conditions in form of these predicates that have to be true for an action to execute. And effect are the conditions that are true after an action is executed. So these can be easily converted to natural language, and you can find clear traceability of how the plan proceeds. But again, creating these PDDL domains is pretty tricky. There are approaches to learn these PDDL domains autonomously, but they are not very scalable. And next, I think people who have worked in single step decision making are very familiar with decision trees as a representation for interpretability, but they can also be used for planning systems that can do sequential decision making. Now they are important because they can decompose predictions into small feature attributions, and you can see clear step-by-step process of how each decision is taken, but then they can overfit a bit, and they are not really great at handling online updates. Though there are some works which are trying this, but still those approaches are not really scalable. And there are other approaches like temporal logic, program synthesis, or rule-based systems, which can also capture how a sequential decision-making system works. There are some hybrid representations also that are not purely symbolic, but have some symbolic components like causal models, which can help user understand how a sequential decision-making system is making its decisions, or some neurosymbolic approaches. And I explained this kind of classification at a formalism type where I talked about symbolic and hybrid approaches, but there are various other forms in which we can kind of classify these representations. And here we try to do it for the kind of representation that we talked about in the paper. But for a detailed discussion, I would ask you to refer to the paper. So what we found out was there is no single representation that is a universal solution for all the kind of problems that we want to tackle. So depending on what domains we are working with and what are our requirements, if you would want to come up with and see, like, you should refer to the table about what you need from your application, and based on that you can choose which representation to use. And in the future, we are planning to have a user study that will more empirically talk about how interpretable easy representation is. And here are a few possible research directions. Okay, so with that, I would like to thank, and if you have any questions, please feel free to ask me or email us. Thank you.